Everyone is talking about exploratory data analysis for AI and machine learning business examples for beginners. In this video, I will explain what EDA really means, how it works, and where it matters. Now let's look at what EDA really means. Exploratory Data Analysis, or EDA, means understanding your data before building a model. It is the first serious check before AI or machine learning work begins. EDA helps you ask simple questions about the dataset. What columns are available? What values are missing? What patterns, problems, and risks are hidden inside? Without EDA, a model may learn from messy or misleading data. Now let's look at what you will learn. First, we will understand why EDA matters before AI and machine learning. Then we will use a business example with sales and customer data. After that, we will walk through the main EDA steps. We will check data structure, missing values, outliers, patterns, and charts. Then we will see how EDA improves machine learning models. Finally, we will cover common beginner mistakes. Now let's look at why EDA matters before AI. Machine learning models learn from data. If the data is wrong, incomplete, biased, or confusing, the model also becomes unreliable. EDA helps us find problems before the model training stage. It shows whether the data is useful for prediction. It also helps us choose better features. In simple words, EDA protects the model from learning the wrong lessons. Now let's look at business example, sales data. Imagine a company wants to predict future sales. The dataset contains customers, products, order dates, regions, prices, discounts, and revenue. Before building a sales prediction model, we need to explore the data. Which products sell the most? Which regions perform better? Do discounts increase sales or reduce profit? EDA helps answer these questions before modeling. Now let's look at business example, customer churn. Now imagine a telecom company wants to predict customer churn. Churn means a customer may stop using the service. The dataset may include usage, complaints, payment delays, plan type, and support history. EDA can show which customers are more likely to leave. Maybe churn is higher after repeated complaints. Maybe churn is higher for customers with low usage. These early insights help the business act faster. Now let's look at step 1, understand the dataset. The first EDA step is understanding the dataset structure. Check how many rows and columns are available. Read the column names carefully. Understand what each column means. Identify numeric, categorical, date, and text fields. Also check whether the target variable is available. This step tells you what kind of problem you are dealing with. Now let's look at step 2, check data types. Data types matter because models treat different data differently. A price column should be numeric. A date column should be stored as a date. A region column is usually categorical. Sometimes numbers are stored as text by mistake. Sometimes dates are stored in different formats. EDA helps detect these issues early. Now let's look at step 3, find missing values. Missing values are one of the most common data problems. A customer age may be blank. A product category may be missing. A delivery date may not be recorded. Missing values can affect analysis and model accuracy. EDA helps us find where data is missing and how serious the problem is. Then we can decide whether to fill, remove, or investigate those values. Now let's look at step 4, find outliers. Outliers are values that look very different from the rest of the data. For example, one order may show a sales value of 1 million when most orders are below 1,000. This could be a real large order. Or it could be a data entry error. EDA helps us identify these unusual values. Outliers are important because they can strongly affect averages and model training. Now let's look at step 5, understand distributions. A distribution shows how values are spread. For example, customer age may be spread between 18 and 80. Sales may be concentrated in a few high-value products. Delivery time may usually be 2 days but sometimes 10 days. Distributions help us understand normal behavior. They also help us detect skewed data and unusual patterns. This is useful before choosing features and models. Now let's look at step 6, discover relationships. EDA is not only about checking single columns. We also need to understand relationships between columns. Does higher discount increase order quantity? Does customer complaint count affect churn? Does delivery delay reduce customer satisfaction? These relationships can become useful model features. Strong relationships help us understand what may influence the target variable. Now let's look at step 7, use charts and visuals. Charts make data easier to understand. Bar charts compare categories like region or product type. Line charts show trends over time. Histograms show how numeric values are distributed. Scatter plots show relationships between two numeric variables. Box plots help identify outliers. Good visuals turn raw data into clear business insights. Now let's look at useful EDA charts for beginners. Use a bar chart to compare sales by region. Use a line chart to see monthly revenue trends. Use a histogram to study customer age or order value. Use a box plot to find unusual delivery times. Use a heat map to study correlation between numeric columns. Use a count plot to compare churn and non-churn customers. Start with simple charts before using complex visuals. Now let's look at how EDA helps feature engineering. Feature engineering means creating better input variables for the model. EDA helps us discover which features may be useful. From order date, we can create month, quarter, weekday, or weekend flag. From customer history, we can create total orders or average order value. From support data, we can create complaint count. These new features can improve model performance. EDA gives clues for creating smarter features. Now let's look at how EDA improves ML models. EDA improves machine learning in many ways. It helps remove bad data and fix errors. It helps handle missing values correctly. It helps detect outliers that may confuse the model. It helps select useful features. It helps understand whether the target variable is balanced or imbalanced. Better EDA usually leads to better models. Now let's look at common beginner mistake 1, jumping directly to modeling. Many beginners start by training a model immediately. This is a mistake. If you skip EDA, you may not understand what the model is learning. You may include wrong columns. You may miss data leakage. You may ignore missing values and outliers. A model built without EDA is often difficult to trust. Now let's look at common beginner mistake 2, ignoring business meaning. EDA is not only a technical activity. It also needs business understanding. A high sales value may be an outlier technically, but normal for enterprise customers. A missing delivery date may mean the order is still open. A zero value may mean no activity, not missing data. Always connect data patterns with real business meaning. This prevents wrong conclusions. Now let's look at common beginner mistake 3, making charts without questions. Charts are useful only when they answer a question. Do not create charts just to make the notebook look full. Ask what you want to learn from each visual. Are we comparing regions? Are we checking trends? Are we finding outliers? Are we studying relationships? Good EDA is question-driven. Now let's look at final content recap. EDA means exploring and understanding data before AI or machine learning modeling. It helps find missing values, outliers, patterns, trends, and relationships. It improves feature engineering and model quality. It also connects technical data analysis with business understanding. For beginners, the best approach is simple. Understand the dataset, clean the data, visualize patterns, and ask business questions. Strong EDA is the foundation of strong machine learning. To wrap up, here is the key takeaway. You now have a structured overview of exploratory data analysis for AI and machine learning business examples for beginners. Review the core ideas, connect them to examples, and revisit concepts like what EDA really means, what you will learn, why EDA matters before AI when practicing. Subscribe to Easy Machine Learning Guide if you want to learn AI through simple explanations and real industry examples.